Well then. And then there were three. Three coronal mass ejections headed toward Earth, that is. Yeah, another one happened late in the day yesterday on July 11th. By the way, thanks for tuning into the Smash News Network, least busted name of news. Congratulations on realizing the channel exists. We are the source for your daily space weather. And the likelihood of additional coronal mass ejections, solar flares, and lots more continues. So let's blast through today's daily space weather show. So here's the southern hemisphere. This is where the latest coronal mass ejection headed toward Earth has come from. You can see this area right here brightening. That is the after effects as plasma splashes back down toward the solar surface following that coronal mass ejection. Not all the plasma escaped. Some of it succumbed to gravity. We do have a very high likelihood of large solar flares, both in the southwestern limb and in the northeastern limb. Here is the southeastern limb for sake of completeness. And here's where the activity has been happening. So that new sunspot that just rose up there has at least produced an M-class flare. Here's an extreme close-up of it. That probably remains the most likely place to see an X-class flare. Although, again, there is an increasing likelihood of an X-class flare in the southwestern limb on the opposite corner. That is the northeastern limb. Here's the northern polar region. You can see a huge plasma filament down there, south of the Earth scale. Also some crown prominence activity there. A solar polar vortex-like situation continues. And no real surprise to our regular viewers, perhaps there. There is the northwestern limb, and there are some sunspots setting up there as well. So, again, a very high likelihood of large solar flares, including the X-class variety. So let's take a look at what's going on with sunspots for a brief moment. We'll show them more in depth here in a minute. There is yesterday plus today, and you can see at least 2 or 3 umbrae there that are larger than the entire planet Earth. One right in the center of the solar disk here, and this one up here in the northeastern limb. Here's a colorized magnetogram, also depicting yesterday plus today, 711 plus 712. And let's take a moment to talk about the channel. Yeah, the channel. We prefer for it to remain in existence, so we've created all sorts of different means by which to do so, to create a sustainable operation. You may have noticed a lot of unsustainable operations over the past 3+ years. Maybe some bureaucratic failures. Well, we can assure you that we are a lot more responsible with your donations than certain bureaucracies are. They'll remain unnamed. And by the way, get 20% off of all the products. We've got over 30 designs in our Redbubble shop. Some of them are more or less provocative. This is Smasher Price, my first scamdemic. And it's got the smashomash.org website, which will redirect you to smashomash.com. We are in the process of beginning a 503c nonprofit science foundation. We do have to build an observatory, and there's a lot of work to do. It's been a slow slog as a result of the, shall we say, stagnant growth on social media accounts. Anyway, feel free to pick up a souvenir there from, and by the way, congratulations on surviving a global scamdemic so far. You've been doing a fine job not being dead. So thanks for that. I'm currently wearing the design. So here's me modeling it. There you go. Just mask the world. I'm sure it'll work. It'll magically start to work. It didn't work during the Black Plague, the Justinian Plague, the Spanish flu, the early 2000s Asian bird flus, and so on. It didn't work in 2020, 2021, 2022, or 2023. But hey, let's keep masking. They're going to work through a process of magic. They will magically become effective all of a sudden. So definitely a great idea. When I go out in public, I am horrified to continue to see masked people. So get yourself a souvenir, and once again, congratulations on surviving a global scamdemic so far. Save 20% on all of the Redbubble designs. And let's talk volcanoes. Yeah, volcanoes. Fagradalsfjall is fixin' to erupt big time. So here is a hazard map by the Icelandic Volcano Group, and they are expecting a huge eruption here. So if you're going on a volcanic vacation, leave your vault pole at home. Don't pole vault the caldera. There is about to be a huge uptick, and there is some deadly gas possibly showing up there around the low-lying regions where if it's not windy, the gas can build up and it can kill you. So please heed those warnings. So yeah, massive fissure eruption there on the Reykjanes Ridge, Iceland. And they're expecting a major uptick here. So this little lull in activity is not expected to continue, especially in light of the large earthquakes that have happened. Those are indications of a lot of magma filling up the tubes below the volcanoes. So activity expected to continue and to increase big time on the Reykjanes Peninsula. Suwanosei Jima also erupting, producing a 7,000-foot ash plume over the Ryukyu Islands. Unknown volcanic ash cloud over Mount Mayan in Philippines. Semeru in Indonesia exploding, flight level 140. It's a 14,000-foot ash plume. 6,000-foot ash plume over Dakono on the Isle of Halmahera, Indonesia. Headed down to North America here, Popocatépetl exploding, flight level 200. It's a 20,000-foot ash plume. Similarly sized ash plume over the also exploding Sangay in Ecuador, flight level 200. Flight level 150 from Ecuador as it explodes, and Sabancaya rounds out the volcano list, exploding with a 23,000-foot ash plume. It's a flight level 230. Again, please do not pole vault the caldera. Let's see what's going on in terms of seismic activity. And there is the past 90 days. A bit of a 7 magnitude earthquake drought happening here. So we are a little bit overdue for one of those. Let's see what's been happening in the past 24 hours. We'll cite quakes of a 5 magnitude or greater. South Sandwich Islands had a 5.1. That was at 14:08 Universal Time yesterday afternoon, right near the Antarctican fault line there. The Antarctican Plate Fault near the South American continent plate boundary. And here's a 5.0 in the middle of nowhere there, the Southern East Pacific Rise at 1726 had a 5.0. South Sandwich Islands had a 5.2 at 1938 Universal Time, close to that other quake we recently reported. North Atlantic had a 5.0. Where was that? Just northeast of the Leeward Islands there, near the Caribbean Atlantic Plate boundary. And last but not least, we've got an Indonesian 5.0 magnitude quake that happened at 8:39 this morning. And let's get back to space. It's a space race. Save face by not being in a place where you're intaking a bunch of space weather nonsense. Here's the past 24 hours in SDO 304 angstroms by itself. And you can see that CME popping off in the lower central solar disk. It does have an Earth-directed component. We will show you some in-depth stuff about that. What's really exciting is stats like the 10.7 centimeter radio flux. So let's cover that next. Before we do that, how about a close-up? There's a sweet money shot. That is the latest coronal mass ejection that is headed toward Earth. You could expect that to arrive sometime on the 15th. Yeah, sometime on the 15th. So it happened late in the day yesterday on the July 11th. Sometime about 2000 Universal Time there. And check out the rest of the stats here. The space weather stats are getting pretty beefy here. The 10.7 centimeter radial flux now at (214) solar flux units. 214 is the 10.7 centimeter radial flux. getting back up over 200 exactly as forecast. I mean, there is a way you can just basically look at sunspots, folks, and if you know how to count sunspots, you can sort of guess. There is the 1-year graph of the radial flux represented by the black line. Sunspot number here reaching a new high for solar cycle 25 at 227. 227 is a sunspot number. With the rising of those sunspots in the northeast, it might get even higher here. So you can expect to even see an uptick in the radial flux possible in the coming days. So that's the 1-year graph. The red line is the sunspot number, the black line is the radial flux, and the pink line is the 30-day sunspot number average. And frankly, it looks like NOAA is dropping the ball here. Also NASA. NOAA and NASA with weird forecasts. I don't quite get it. Here's the NASA forecast, and they've only got one CME modeled in the opposite direction. So NASA not forecasting any CME impacts whatsoever. We're now forecasting 3 in the coming days. Here's NOAA's so that was NASA's Enlil spiral. Here is NOAA's Enlil spiral. You can see NOAA's expecting an impact here at Earth. Not until early in the day on the 15th, right around midnight Universal Time. So that's, I don't know, that's kind of weird. We're expecting a possible aurora borealis visible at mid-latitudes on Thursday evening. Now that first CME might arrive a little earlier, and it might actually have an effect on the U.S. power grid, just so you're aware of that. If the CME strikes around, noontime for California, let's say, if the CME strikes around noontime for California, it could create significant issues with the power grid because California's power grid already sucks. So, just so you're aware of that, when a CME strikes around noontime, there is a lot more induction into a power grid, especially in the summertime when air conditioning is running and so on. That is a huge draw on power. So that could actually have some effects there. Not sure what's going on with NOAA's forecast. We'll just take that with a truckload of salt. And here you can see they're forecasting some geomagnetic unrest tonight into tomorrow morning. So that is some disparity there. So yeah, so it's possible that tonight into tomorrow we may see the aurora. So we'll just keep an eye out both nights, and we'll talk about some ways to monitor where the aurora is likely going to be visible in your area here in a minute. First, let's take a look at some more space weather stats. Here come the past 4 hours of Earth's magnetic moment from space. This is basically what a proton experiences when it crashes into Earth's magnetosphere. It's got to either bounce off or slow down a lot and start obeying those magnetic field force lines that you see drawn up there around where you see high pressure. That is Earth's magnetosphere. So that is the past 4 hours of Earth's magnetic moment from space to about 12 Earth diameters. The units depicted here are modeled in nanopascals, magnetohydrodynamic pressure. Nanopascals for the past 4 hours. Things are calm at the moment. Ground magnetic perturbations is a great map to use if you are expecting to see the aurora in your area. This is near real-time data. It is 4 hours. It depicts the most likely places that you'll see telluric currents, pipeline, railway, and power grid induction, and indeed the aurora. So that is one to watch. Keep in mind the aurora can come and go very quickly. You must forecast it to get to the right place at the right time. And for you North Americans, try this top view here, the Geospace Delta B ground magnetic perturbations map for North America. It does work quite well, as we have used it in the past to take imagery of the aurora here from Lehigh Valley, Pennsylvania. So we're way down here, and we may see the aurora even farther south than that, maybe even as far south as North Carolina. So some significant CMEs headed this way. I'm not sure what the major space agencies are up to, but I suspect they are incorrect. And that's the way science works, folks. You got to just take your chances, and then if If there's a learning experience available there, then you get ahead of it. So one of the ways you can monitor the aurora also is with this 30-minute forecast model. This isn't my favorite. I don't think it's as accurate as some other models, but you could check this one out. This will give you some idea also for both hemispheres. The Boulder magnetometer is going to show some variation. So that's another one. You can find links below all of these items at the Space Weather Prediction Center. Just scroll down to the bottom and see the Boulder magnetometer. You'll see variations happening in this one. CMEs strike typically. So that is another thing to check. And that shows only a few hours there of data. So that'll be updating. So that's another thing you can check to see when impacts are happening. And I think the best one of all is this one right here. It's a empirical information about the amount of induced power in the grid. So it's actually showing you the electric field there, millivolts per kilometer. So when you see your area light up, that's going to be a likely moment when you can see the aurora there. Again, keep in mind these things happen very quickly. These particles are moving at very high speeds. And the aurora can turn off and on very quickly. So be diligent if you're trying to take videos and photos of the aurora. Just get yourself set up for a while. Get comfy. Get your camera set up correctly. You know, tripod, all of that sort of stuff. And make sure you take imagery of the aurora because it's mostly ultraviolet light, which means most of the aurora is not visible to the naked eye, but it's visible to your digital camera device. So you may have noticed you can see your remote, which is infrared spectrum. You know, your like TV remote, for example, is infrared spectrum, and your camera can see it. So your camera can see a lot more of the electromagnetic spectrum than the naked eye can. So that's why we encourage our viewers to take photographs and videos of the aurora, because it will expose spectra that are not visible to the naked eye. So that's one of the great ones. You can use the Geoelectric Field Map US and Canada. Geoelectric field models US and Canada 1D and 3D EMTF CONUS. So current conditions are quite calm here. It is KP 1.33 at the moment. KP 1.33 is the current situation, and we can expect to see this way up here at KP 6+. I'm not expecting it to get over KP 6.33, but you never know. Sometimes these CMEs are accompanied by a very strong magnetic field with a very powerful negative BZ component. So here's the real-time solar wind. Pretty uneventful here for the past 24 hours. A little spike happening here. Looks like a minor CME impact there. It's barely even noteworthy. Current conditions are only 325 kilometers per second for the solar wind speed, so a very slow solar wind speed. Solar wind density here about 4.5 protons per cubic centimeter. Again, pretty unremarkable. And although we do have a strong negative BZ component up here, so this red line is the sort of the most important line when it comes to whether or not a CME impact will have a strong geomagnetic storm effect. If you have a strong negative BZ, it induces a lot of current. And if you have a strong positive BZ, it's more of a push effect. Not quite the same as when you have a negative BZ, which induces current and creates geomagnetic storm conditions. Next are magnetometers. We'll look at the GOES magnetometers as well as ground-based polarimeter magnetometer data. So there are the magnetometers for the GOES 16 and GOES 18. Those will be all over the place when the CMEs impact, and it's going to be several days of activity here. So should be an exciting time for space weather. So here's our top view ecliptic plane field plot, and this is a super fantastic way to forecast. I mean, we've shown repeatedly on the channel that with this we can actually forecast sunspot formation before it occurs sometimes. The top view ecliptic plane field plot, it's derived from 51 ground-based magnetometers. Magnetometers on stereo A, which is that little plus sign to the left of the Earth there, and stereo B, which is actually overlapping the Earth image. And the floodgates are open for solar maximum, folks, so we are now prepared for solar maximum to show up. Now that that North Pole magnetism has finally left the North Heliographic Polar region, again, floodgates are open for solar maximum. They weren't until just a few days ago. See our previous daily space weather videos for details on that. Here's our line of sight field plot depicting the photosphere magnetogram in grayscale, solar B field in blue, north and south polar fields in green and red respectively, which brings us to coronal holes. So we've got some south pole coronal holes, and we've got some indecision happening here in the northeastern limb. We've got north and south pole oriented coronal holes there, as some chaos is happening in the sun's atmosphere finally, and this is starting to look more like a ramp up to solar maximum. So there you go, coronal holes. And let's take a look at coronal holes from SDO. Yeah, SDO. It's good times. And before we do that, actually, let's take a look at the last 24 hours in 171 angstroms. So there's the house favorite wavelength and consumer tip about 171 angstroms. It sucks at showing solar flares. So there are some M-class events that happen up here, and they're not very visible. It's just a feature of that wavelength. But don't worry, there are some much better wavelengths to view solar flares. And a better wavelength to view coronal holes is 211 angstroms. So there is the past 24 hours in that wavelength, another species of ionized iron. And you see that CME happening down there in the south. Also a coronal hole opening up just to its south. Or at least the coronal hole being exposed by less plasma in the corona there. So perhaps even being filled in was that coronal hole. Pretty interesting. There's a CME happening, there's the coronal hole opening, and there's the coronal hole reclosing. So that's an interesting feature indeed, and let's move to sunspots. So the first thing we'll look at here is the Integrated Space Weather Analysis Center. Again, we've got two sunspots with umbrae larger than Earth here, 3363, right in the center of the solar disk. And it is quite magnetically complex. It does have some trailing opposite polarity umbrae there. So it's actually got some potential to produce large flares. But 3372 is certainly the main solar flare producer. That's up in the upper left there, the northeastern limb. And then, of course, the series of sunspots in the southwestern limb. Sunspots like 3359, 3358. So those are the two areas where it's very likely to see a large flare here. And keep in mind, folks, flares can be forecasted. We just don't really worry about it that much because, well, there's a lot of stuff to do. And a lot of fundraising to do, let's just say. Because we would prefer to keep these videos existent, free for all to view, and publicly visible. So here's the past 24 hours, and we've got 304 angstroms along with the SDO magnetogram here. So this is just awesome because it is good at showing flares, as well as the way the helium portion of the solar atmosphere interacts with those magnetic fields. The plasma aligns to the magnetic field lines, folks. The plasma aligns to the magnetic field lines. It's not magic, and most of the stuff that we cover on the channel is actually predictable. So we use magnetic shear to predict when a large solar flare is likely. And this sunspot group features quite a lot of magnetic shear. So that's a fantastic view there. The SDO magnetogram plus 304 angstroms ionized helium. Moving along to more sunspot features, here is the SDO continuum, along with 304 angstroms. Again, ionized helium. And here we'll drop the 304 angstroms to just show those huge sunspots. So again, a giant sunspot here right in the Earth-facing portion of the solar disk, otherwise known as the Earth Strike Zone. Yeah, huge sunspot right in the Earth's strike zone. And also a very high likelihood of large solar flares. Not only in the western limb, but also in the eastern limb. It's exciting times for space weather, and just expect it to get better and better, folks. It's still not solar maximum. So keep that in mind. So next, solar energetic particle events, and we ain't got none. The ghost proton flux here remaining flatline despite some flares. And here's the flare situation. Multiple M-class flares here. So 1, 2, 3, 4, 5, 6, 7 M-class flares in the past 24. Make it 8 M-class flares in the past 24 hours. It's been pretty high activity on the closest star. And again, expect it to only get higher in the coming days. Here come our solar flare images. Dag! That is good stuff. So I would attract your attention to the northeastern limb in your upper left. That is where those flares have occurred. I think it looks like all of those M-class flares were from that area. What's that? You want a closer look? The equatorial zoom isn't close enough for you? Before we do that, a quick reminder that this area right here still has a propensity to produce an X-class solar flare. Don't be surprised to see one come from that region. Although I do suspect that the most likely place to see an X-class flare is up here. So that is some fantastic imagery from SDO. Once again, the 131 angstroms wavelength is another species of ionized iron. And that is a lot of solar flares. And you can just expect more, as we are still quite a ways out from solar maximum. You can expect levels of activity similar to this for the next nearly 2 years. It's exciting times for space weather. And exciting times for the Smash News Network, least busted name in news. We're going to cover coronal mass ejections here since we've got yet another one on the way. It's exciting stuff. And once again, we are in the process of creating a sustainable operation here. So obviously, we're paid just this side of nothing to put the content on YouTube. So we've created various different value-added services, like our Hemp Lucid affiliate. It's one of the several paid promotions that are in this video. So check that out. I have recently consumed a focus mushroom gummy. They don't make me jittery. I don't really notice any like stimulant type effects when I take the focus mushroom gummies. Mine are in grape. You can also get mushroom gummies for sleep or for stress or in a variety pack. So if you haven't checked out the focus mushroom gummies, check those out. They do have, what do they have? They've got lion's mane, tyrosine, theanine. They've got some green coffee extract caffeine, cannabigerol, cannabidol full spectrum, and tetrahydrocannabinol full spectrum oil. So check those out if you haven't. The focus mushroom gummies, quite tasty. And they don't make me jittery. I mean, some people suggest that you take only half at a time if you're just getting started with these. But I am a regular user of those focus mushroom gummies, so check those out. You can find a link to the Hemp Lucid shop below this video, and you can also find it on the homepage at smashomash.com. So help out the channel that way, maybe help out your own health, maybe help out your own performance with the focus mushroom gummies, etc. Today's featured product from the Amazon shop is, well, if you like Frisbees, I suggest this one. I own one. Mine's actually blue. And that is the best Frisbee you'll ever own. It has all kinds of aerodynamic advantages with the lenticular shape, the shape of the rim. It's extremely stable Frisbee there, even in high wind conditions. So check out our new list. We actually put up a recently new list here under amusement, and the way that I amuse myself is typically with weird science instruments and doing all kinds of stuff. Weird things. Yeah, when I'm a billionaire, don't worry, folks. I'll do really weird stuff. It's coming. SmashOmash.com is the homepage. You can find the Hemp Lucid shop, the Amazon shop, Instagram. We're on Threads, Patreon. You can find a permanent invite link to the Discord chat. You can find our music label at Spotify. It's also on Amazon Music, on YouTube Music. Links to the Redbubble shop there. Once again, congratulations on surviving a global scandemic so far. And welcome to the Neo-Renaissance. SmashOmash.com. We launched it back in 2019 because we saw the writing on the wall. Again, we are also on Threads. Link on the homepage to that. And make sure you follow us on Instagram. Look for additional content coming to Instagram. We are doing a big-time renovation with all of our content creation. So one of our changes will be more Instagram posts. So you can find us all over the internet at SmashOmash.com. And let's take a look at what's going on overhead here before we move to coronal mass ejections. We want to orient our viewers. So this is the star chart over Lehigh Valley, PA at the moment. One of the world's top cycling communities. Yeah, one of the top cycling communities in the whole world. If you're going on a cycling vacation, come visit us. I, as a pro cyclist, am more likely to go on a vacation from cycling than on a vacation to go cycling. Anyway, we've got Saturn, Jupiter, and the Moon up there overhead at the moment. They're not visible because it's light out, and I think it's cloudy as well. But in any case, Mercury trailing the Sun there. So if you're viewing the evening sky, you may have a view of Mercury and also Venus and Mars there, still hanging out quite close to each other on the ecliptic. Great time to view those. And again, remember, folks, before light tomorrow, there may be some CMEs impacting. So we will send out email alerts about that. You can sign up for email alerts for free at the bronze level at smashomash.com/smashteam. We also send out alerts about videos just like this one. So you may want to do that, especially if you're not getting notifications from certain video hosting platforms and other pathetic big tech censored sites. So here's what's going on in the solar system. And we'll do a 1-week forecast. By the way, one of the things that's going on in the solar system is that a bunch of CMEs are propagating out from the sun about to strike Earth. 3 are now on the way. Here's your 1-week forecast for what's going on in the solar system. In 1 week, we will have a tiny sliver of a moon, a crescent waxing. And here come CMEs. Yeah, CMEs. And there are certainly three of them making their way out through the solar system. The only question is, are they headed this way or are they headed away from Earth? So there's the one that happened late in the day yesterday that we talked about earlier in the video. We showed a close-up of it ejecting. We showed the Hyder flares that are associated with part of the filament collapsing back toward the chromosphere, and you can see a partial halo on these images because that CME likely has an earthly directed component. So that came out around 2000 Universal Time yesterday. That's 102 frames from yesterday, July 11th. Here we'll show an additional 36 frames from today. So it looks like no more CMEs since then. And let's pause this right here. So let's bring this one back also. So here's that CME coming out, and you can see a halo there. So 2230, a little earlier on the C2. And let's bring those back and let those play through one more time. And those are likely to arrive early in the day on the 15th. Yeah, early in the day on the 15th. You can expect additional CMEs to show up. And that should be a good time for North American Aurora viewers. So here is the view from Stereo A. We're going to show that as well, since it does show some additional data there. Actually, Stereo A is lacking today, so Stereo A not helping at all. We've got quite a lot of missing data there, like 16 hours of missing data from Stereo A. Again, there's the view from Soho Lasco C3. You can see indeed at least a partial halo eruption there. There's an event that precedes it, but there is a partial halo there, so we do expect that to be an earthly directed CME. And before we get to filaments, let's show our custom videos. And they are pretty sweet. So there's a 24-hour video featuring SDO 193 angstroms. You can see Soho Lasco C3 in blue, C2 in red. CMEs. There is now a third on the way. There's an even closer view. Great view of that filament ejection and collapse. You see that brightening there? That's called a hider flare. That is a secondary feature to a CME that often happens when plasma makes its way back down toward the surface of the sun. And here is just 193 angstroms by itself. And there it goes. Or I should say, here it comes. All right, so next we'll talk filaments. And it is definitely an exciting time for filaments. I mean, you can see them in these wavelengths. The 304 plus 171 angstroms, huge filament up here. Most of the filamentary material down here has either collapsed or been flung in your direction. Let's take a look at some more views here. Here's the view from Lermonth. Yeah, so Lermonth, Australia. And quite a lot of filaments in the northern hemisphere. There's 1, there's 2, there's 3. There's some big ones about to set down here in the southwest as well. Also, it looks like a new one just rose up here right around the equator. So very high propensity for additional coronal mass ejections. The likelihood is nearly 100%. Yeah, so there you go. Lots of stuff going on. And by the way, if you want to name those filaments after living people, just join us over on Twitter. Follow the hashtag #NameThatFilament. Tell us which one you want named. And you can name a filament after your favorite or maybe your least favorite or people that you're neutral on. I don't know. It's Twitter, and it doesn't have 500 million daily users. Or even 1 billion. It doesn't have over 2 billion users per month like YouTube does or like TikTok does, etc. Anyway, Instagram. It's got way more viewers than Twitter. Way more. It's not even close. It's not even in the ballpark. So here are the past 2.5 hours from the GOES 18 SUVI. Ionized helium. And the activity from this sunspot up here just continues. So this is the most likely place to see an X-class flare. Second most likely place to see an X-class flare is down here. But there is a likelihood for major flares in other locations as well. There are multiple sunspot groups that are at least of beta-gamma class. And that brings us to bonus features. Yeah, because we cover a lot more than just the basic stuff. We cover complicated stuff. Satellite charging hazards are currently non-existent. It's smooth sailing for satellites. So no charging hazards of the surface or internal charging variety. GOES electron flux here a little bit lower than it's been, and you can expect this to be very, very low in the coming days, as the ionosphere is going to be puffing up and creating erroneous readings for the GOES electron flux. Why? Because the GOES electron flux is measured using radiography from a geosynchronous orbit. So those geosynchronous satellites are very high up. They're at 23,500 miles of altitude, and they're measuring the electron flux all the way down at the F layer of the ionosphere. So they're at 23,500 miles of altitude. They're measuring the electron flux at like 300 kilometers of altitude. And they use radiography that for that to, they use signal refraction radiography to determine the amount of refraction for the signal. That's how they use radiography to measure the F flare from so high above it. So there's the 1-year graph of the electron flux. To put that in context, again, you can expect a big dip in this in the coming days. And NOAA is forecasting a kind of a small dip. I won't argue with that. It might be a little bit lower here. Might be down here instead. So remember, tomorrow we may see early in the morning, and we may see a major power grid impacts in the U.S. Because again, if we see CME impacts happening around noontime, especially in the summer when you've got air conditioners turned on, you could see huge spikes in the power grid. So there could be some issues with it. I find it unlikely for first world nations, but you gotta over forecast, not under forecast. That is how we do it with respect to hurricanes and blizzards and ice storms and space weather. Hopefully Elon Musk is currently watching the videos and not going to launch Starlink satellites and destroy them all, despite our forecast for geomagnetic storm conditions. So let's show the F flare of the ionosphere and the vibrational frequency therein. Feel free to pause the video on this frame if you're not familiar with the data depicted. And here is the F flare. It's looking pretty normal at the moment. And we're expecting big low-frequency anomalies showing up when those CMEs impact. Here's the anomaly from megahertz. The anomaly in megahertz from a 30-day median. Again, the ionosphere here is pretty normal. You can expect to see a lot of red on this in the coming days. In fact, possibly as early as tomorrow's space weather video might feature a lot of low-frequency anomalies in this, which is the tendency for what occurs as the ionosphere puffs up because solar plasma arrives, affecting the Earth system. Anyway, there's the latest image, 11:45 Universal Time ionogram, 12 o'clock Universal Time anomalygram. We also show total electron content daily on the channel because you never know when a signal will arrive in your archive data. So feel free to pause the video on this frame if you're not familiar with those distances in miles. Here is the total electron content forecast, and we're seeing major high electron content anomalies here south of the Indian Ocean, in the Southern Ocean, Antarctica, and south of Africa, and south of the Atlantic Ocean. So check it out. A lot of high electron content anomalies there showing up very far south. We'll let that play through one more time as it is fraught with anomalies there. Check it out. It's a lot of electrons quite a bit out of place there. So some major GPS errors likely to happen in places perhaps unexpectedly. If you're in a populated area, try turning on Wi-Fi location accuracy to improve your GPS location accuracy. Next, the total electron content anomaly from the 10-day average. And of course, we like to show this for North America because if it does have some sort of a Earth-generated pre-earthquake signal, we would like to show it on the channel. Now, this is typically, we would expect it to only forecast earthquakes of a 6+ magnitude with a time window of about 4 days, is according to the scientific literature what you might see here. So we are seeing some anomalies there over southern Mexico. So those could be those Earth-generated signals, or they could be space weather. Either way, if it shows up in the space weather data, if it has predictive value, we are interested in it. And when we talk about predictive value, if you want to read more about our mission, of course, we've got a narrower mission for smashomash.org. However, if you read the mission on the Smash forum, smashomash.com/forum/mission, we're interested in phenomenon that has predictive value. So that is why we show it daily on the channel. You never know when you'll find a signal somewhere where you weren't expecting to see it. Because in science, oftentimes you end up with answers to questions not asked. So be Ulysses and make sure you follow that to its logical conclusion. If you are ossified on your beliefs, you might be looking at a bunch of nonsense to try to prop up your theories, where you are better off being more flexible and figuring out the reality as opposed to trying to prove your theories especially if they've been massively debunked. So anyway, we've got many sunspots here with complex magnetic fields. That sunspot there is beta gamma class. That sunspot there is beta gamma delta class. This sunspot down here is at least beta gamma class. This one over here is beta gamma delta class now. So that's interesting to say the least. That sunspot is huge. And it is, well, it is beta gamma delta class, but just barely. So it's actually gaining some magnetic complexity here. If this grows a bunch of trailing North Pole umbrae, it could be major fireworks for that one. This one down here, that one is beta gamma class, at least. And of course, this one up here I suspect is beta gamma delta class just based on its behavior. And there's the rock back to those magnetic fields. And we do have some strong South Pole trailing umbrae there, so it's beta gamma delta class. And that is where we will close out the daily space weather content. And move on to meteorology. So check out the Saharan dust situation. That's the DUX. That's optical thickness to 550 nanometers, aerosol dust extinction. And it's pretty dusty in the south central Atlantic. That dust making it all the way to the Caribbean, fertilizing the lush Caribbean environment. Also tamping down hurricane systems, making it less likely for them to form in that equatorial Atlantic. Anyway, let's move to our regularly scheduled meteorological section. Here's what's going on for surface winds in the eastern world. By the way, if you're in this part of the eastern world, press the share button. Also, if you're in this part of the eastern world, or in this part of the eastern world, or in any part of the universe, press the share button, as we are not satisfied with YouTube's recommendations, despite our use of hashtags and all the other features available on the platform. Here are the jet streams of the eastern world. And the jet stream is blowing backwards over the Indian Ocean. Here are the jet streams of the central world. Here are the surface winds of this side of the planet. And here are the surface winds of the Americas. Last but not least, the jet streams of the Americas, probably the best single feature to forecast global scale weather patterns. And if you think mankind is controlling global scale weather patterns, well, mankind would have to control those 250 millibar or 250 hectopascal winds, and mankind is incapable of doing that. It's cute that people think humans can control the weather on that scale. It's just that they should take physics and understand things like wattage before they suggest that HARP controls the jet streams or some ridiculous nonsense like this. Now we're looking at windy.com's sea surface temperatures, just to give you an idea of ocean temperatures. It's cold on the left coast of the U.S., and it's quite warm around the Gulf. That's your sea surface temperature report. And here is your clouds and fog view for the Americas. That is shortwave radiation, as it's still dark over half of that map. So we don't use a visible satellite. We use the shortwave 3.9 micrometer infrared radiation map. It shows clouds and fog at nighttime. And if you're too lazy to look outside to see if it's clear out to see the aurora, you could use the shortwave radiation map. Fingers crossed for clear skies for all of our pals viewing the aurora around the world. If you do get any videos or pictures of the aurora, drop us a line on Instagram or Twitter especially. You can also send us your auroral image or whatever imagery to our Discord chat. Permanent invite link on the homepage at smashomash.com. Here is your weather.org. Weather.gov, rather. Weather.gov. By the way, Who owns weather.gov.org anyway? What's up with weather.org? Weather.org. There you go. That's a thing too. I don't know. Whatever. Weather.gov is the site that we typically show. There is your alert map. There is the key. We've got a lot of high heat warnings here in the southern U.S. Excessive heat warnings, red flag warnings, etc. Also some severe weather there in the central part of the country. Here come some forecasts. That is your GFS 72-hour temperature anomaly forecast in degrees Celsius. Some wild temperature variations happening in certain portions of the country here. Places like the Gulf Coast, Texas, also Colorado, as all that hot air tries to reach static equilibrium. Here is the jet stream forecast. Again, the jet stream is primarily in charge of pushing weather systems from west to east, and when it doesn't do so, that's when you get weird weather. If you think mankind controls the weather, mankind would have to control those features, which is just a ridiculous notion. That map is thousands of miles long, and that's not how it's, It's a GFS 72-hour jet stream forecast depicting the 250 millibar winds. Here is our pressure and precipitation forecast for the same period and the same model, the GFS 72-hour model. And there will be quite a few thunderstorms around the U.S. in the next coming 3 days. Moving right along to our lightning mapper. That's what's been going on for the past about 10 hours. Strong system here moving across into the central U.S. here, making it toward the Ohio Valley. And here's the current situation. Give that a moment to spool up. We'll briefly show this real-time lightning map from lightningmaps.org. And currently some systems here moving toward Chicago, across Iowa. There's your full lightningmaps.org view. And by the way, these videos were brought to you in part by the Smash Team. So thanks to the Smash Team, especially the gold and silver Smash Team level. Smashomash.com/Smash Team is the official subscription services site of this channel. We are still on Patreon. You can still donate to the cause that way. You can find all these links here and so on, obviously. Smashomash.com/Smash Team. We send out email alerts for disasters, for space weather, and even to announce the release of videos like this one. So sign up for those. You can join at the bronze level. That'll cost you $0 per month. Silver is $2.99 a month, and gold is $9.99 a month. All kinds of additional features available and additional content by becoming a member of the Smash Team. Again, these videos are brought to you at massive personal risk and expense by Smash staff and I. And again, trying to make this into a sustainable operation, creating our own financials and our own website system. Smashomash.com/Smash Team. Just log in, or you can even click posts, because some of the posts are visible without even logging in. But your best bet is to log in and sign up for email alerts. If you want to send us exactly nothing per month, the bronze level enables you to do that, and you'll still receive some additional content at smashomash.com/Smash Team. We'll close out the video with a close-up of these systems, and there's some quite severe weather here moving across. That is your U.S. Doppler radar map. And it's going to be extended periods of heavy precipitation there in Chicago. Also, Davenport's going to get kaplastered. Davenport's going to get kaplastered. Here's the full 50 states view. And last but not least, here's the lower 48 view. Here is clouds and fog. And last but not least, the water vapor map. It looks like clear skies over both Wyoming and Colorado there, as we see dry, massive air over those locations. And some rapid cloud nucleation happening there over the Arkansas-Louisiana border. Here's your recap. It's U.S. Doppler radar. Here is clouds and fog, depicted in 3.9 micrometer infrared radiation, the shortwave NASA GOES interactive weather satellite. And here is the 6.19 micrometer infrared radiation, which shows water vapor as in all of it. Another of the great features of the NASA GOES Interactive Weather Satellite Suite. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Once again, congratulations on realizing the channel exists. Don't forget to visit the links below the video. Save 20% on your souvenir. And in the meantime, we hope your bunker is properly fortified. Since I've been spooked by all this spooky, scary stuff. Dude, there's a galaxy. Look out, folks. Galaxy. Oh, my God. Galaxy space. Oh, no. I'm so spooked. Time to head back to the bunker. In the meantime, may that solar wind be at your back. Going back to the bunker again. Whoa.